Hello everyone, today I'm going to go over some more information regarding kinetic and potential energy. Don't forget that this time next week, next Thursday, Friday, you will need a ball or something that can bounce. If you don't have a ball or something that can bounce, I will make sure that there is an alternative if you don't have that particular object, so no worries about that. So let's get into today's lesson. All right, so first off, as you're watching this video, I just want you guys to kind of think to yourself, why doesn't the water balloon hit Mr. Silva's face? So let's watch this video. It's a short one. And now here is my second question. What types of energy does the water balloon have? Every object has energy associated with it. That energy can be due to the position of the object's motion, the chemical bonds that make up the object, or many other factors. So that pencil that might be in your hands has energy. What types of energy might be present in this photo of this girl swinging? Whenever an object is moving, it has the ability to do work. For instance, when an archer releases an arrow, the arrow will move. Every moving object has the ability to do work, therefore every moving object has kinetic energy. Kinetic energy, again, is the energy associated with motion. An object does not need to be moving to have the ability to do work. Imagine a stretched rubber band. It has the ability to do work because it has been stretched, not because it's moving. Likewise, imagine a cat sitting in a cat tree, like this one. Because of its position, it now has the potential to do work. Potential energy is the energy associated with the condition or position of an object. Some forms of potential energy depend on an object's condition. Elastic potential energy, represented by our gray cat down there, is the energy associated with objects that are stretched or compressed. Gravitational potential energy is the energy that an object has due to its position relative to Earth. So the gray cat who's trying to squeeze under the door has some elastic potential energy there, right? Because he has to squeeze his body to be able to fit underneath that hole. The other cat with the cat tree has gravitational potential energy because he's up above the ground, and if he were to hop up into the next part, he would have even more gravitational potential energy because he would have even more height. The energy of an object depends on many factors. Different types and forms of energy are affected by different factors. Kinetic energy depends on the mass and speed of an object. Gravitational potential energy depends on the mass of an object and its height above ground. So if we look here at these two examples, we have a student riding a bike and a moving car. They both have kinetic energy, but which one has more kinetic energy? The car. The car would have more kinetic energy because it has more mass and it can probably also reach greater speeds than a student riding a bicycle. The kinetic energy of an object depends on both the mass and the speed of the object. An object that is moving more quickly will have more kinetic energy than an identical object moving more slowly. Increasing an object's mass will also increase its kinetic energy. So if we look over here, what you have is the formula for energy. Ke is equal to 1/2 mass times velocity squared. So what this tells us is that the greater its speed, the greater the kinetic energy. In fact, the greater the speed, its energy will be also raised to the second power. Greater mass will also result in a greater kinetic energy, but velocity definitely has a greater effect on kinetic energy. And what you're seeing here, right, is again, and this broken down, right? So if we have the two bowling balls with equal masses, then the one with the greater velocity has greater kinetic energy, less velocity, less kinetic energy. And then if we're looking at the other example of just equal velocities, the bowling ball will clearly have more kinetic energy because it has more mass, whereas this other smaller ball, less mass, which will give it less kinetic energy. Gravitational potential energy of an object depends on the object's height. The farther an object can fall, the more gravitational potential energy it has. This energy also depends on the mass of the object. So here what you're seeing is again an equation, but this is the equation for gravitational energy. So mass times the acceleration due to gravity times the height of the object. So here you can see that mass and height kind of have an equal effect with regards to gravitational potential energy. So what we're seeing here in the picture is just sort of the effect of, right, the blue skier will have more gravitational potential energy because he's at a higher height compared to the red skier. And then here in the next example, the green and the red skier, the green has more gravitational potential energy because he has a larger mass compared to the red skier. All right. And then finally, just to kind of sum up what we've just talked about, potential energy is stored energy. So the ball at this high point will have more gravitational potential energy compared to when it goes or sits at the bottom. And then kinetic energy is an active energy or an energy due to motion. So when it's moving, it will have kinetic energy, and as it moves faster, it will have more kinetic energy. And that's just what you see here again. If you're at the top of the slide, you have gravitational potential energy. And then as you go down the slide, you have kinetic energy because now you're in motion. And there you have kinetic and potential energy.